All right, so we're going to look at solving equations part 2. So we've dealt with solving equations part 1, and now we're going to deal with solving equations part 2. And part 1 dealt a lot with dealing with the addition inverse and the subtraction inverse, which again, inverse just basically means opposite. And so with part 2, we're going to be dealing with a lot with multiplication and division. So our goal for solving equations part 2 is the same as it was for solving equations for part 1. It is to get the variable by itself on one side of the equal sign. So it doesn't matter what side the variable starts on. We want to get that variable by itself on one of the sides. Ideally, so if the variable starts on the left, we want to get it by itself on the left. The variable starts on the right, we want to get it by itself on the right. How we do this is we're going to solve using the inverse operation. So just like we did with part 1, we're solving using the inverse operation. The multiplicative, funny word, but basically it's just multiplication, multiplicative inverse. So what is the inverse operation of multiplication? Is division. And the division inverse, all right, it's not divisionicative, okay, it's just regular division inverse. So what is the inverse operation from division? It is multiplication. And then we know we're done when the variable is by itself. That's how we know we're done. All right, so let's look at some examples here. All right, so let's look at example 1. Example 1, let's say we have, let's go with 4y equals, let's go with 24. 4y equals 24. Well, when we have a number next to a variable, so this number 4 is next to the variable y, this means we have 4 times y. All right, so basically we need to figure out what number can I multiply by 4 to get 24. Well, I know a lot of you guys could probably do this in your head. That's why I did an example like this. But we need to identify, so we're multiplying, we need to use the multiplicative inverse, or the inverse operation, which is division. So we're going to divide, and we're going to use a fraction bar as our division sign. We're going to divide by 4 on the left, and then we're going to divide by 4 on the right. Because remember, what we do to one side, we have to do the other. Well, 4 divided by 4 is 1, so those go away, leaving us just with y equals 24 divided by 4. 24 divided by 4 is 6. Okay. So this is how we do this, right? With 4 times y equals 24. We divide by 4 on both sides, and we use division as like a fraction bar. That's what we're going to use for division. All right. So let's look at example 2. So if you remember, I used a fraction bar as my division. So what if I have, let's say, a divided by, so again, I'm going to use a fraction bar as division, right? But that just means division. So a, some value for a, divided by 5 equals 6. All right, so this looks kind of funky. You're like, wait, what? So we have some number divided by 5 has to be an answer of 6. So what number can we divide by 5 to get 6? All right, well, we know we're dealing with division, so we need to use the division inverse, which is multiplication. So we want to get a by itself, so we're going to multiply the left side by 5, because to undo division, we multiply. 5 divided by 5 is 1. And since I multiplied by 5 on the left, I have to multiply by 5 on the right. This leaves me with A equals, well, what's 6 times 5? 6 times 5 is 30. Boom, now I'm done. And again, we can check to see, we can substitute this back in. So we had A over 5. Well, A is now 30. So I can substitute this in. I could do 30 divided by 5. Well, what is 30 divided by 5? 30 divided by 5 is 6. Okay, and that's what we were supposed to get. We were supposed to get 6. All right, let's look at another example here. Let's do number 3. Okay, what if I have, let's go with negative 63 equals 7m. Negative 63 equals 7m. This time it looks a little different. My variable's on the right, but I'm still using the same thing. I just want this time my variable is going to be by itself on the right hand side. All right. So we have 7 times m equals negative 63. So what can we multiply by 7 to get negative 63? Well, if we notice we're multiplying, so we need to use the inverse operation of multiplication, which is division. So we're going to divide by 7 because that turns into 1, so they go away. And then I also need to divide this side by 7. All right, leaving us with m equals, now this is where you need to pay attention, 63 divided by 7. Well, 63 divided by 7 is 9. And then we have a negative and a positive. A negative and a positive would be a negative. I know we didn't go over division, but division is just like multiplication when it comes to the positive negative rules. So m equals negative 9. I can again substitute this in. So if I take negative 9, put it in for m, I have 7 times negative 9. 7 times negative 9 is going to give me negative 63. So that's where, boom, we know. Kapow, firepower, we did well. And let's go with example 4. All right, example 4. Let's go with negative 8 equals, go with x over negative 3. All right. So even though this is just like this problem up here, except for now my variable's on the right. So I have something divided by negative 3 is going to give me negative 8. So we need to figure out what we can plug in for x. Well, what's happening between the variable and the number? It's division. So we're going to do the division inverse, which is multiplication. And we're going to multiply by whatever's on the bottom. Well, see, on the bottom's a negative 3. So I need to multiply by negative 3. All right. I can't multiply by a positive 3. I need to multiply by a negative 3 to make those go away. I have to multiply by whatever's on the bottom. If I multiply by negative 3 on the right, I have to multiply by negative 3 on the left, leaving me with x equals, well, negative 3 times negative 8. 8 times 3 is 24. Negative times a negative is a positive. Boom, pow, firepower. All right. So that is solving equations part 2. It's just dealing with multiplication and division. Again, the biggest thing is identify what operation is happening between the number and the variable. If it's multiplication, we divide. If it's division, we multiply. That's how we do this.